Welcome to Brain Vision.
In this example, we are going to calculate the temperature for a few different tanks of ideal gas here. So we're going to assume that the number of moles for every tank of gas is 0.1 moles, and then we're just going to change the pressures and the volumes and see how the temperature changes. So the first thing we're going to have to do is get our equation in order here. So if we recall the ideal gas law, PV equals nRT. If we want to solve for the temperature, we'll have to divide both sides of this equation by nR. Oh, jumping the gun there. And we'll just have T is equal to P times V over nR. So now all we have to do, since we know N is going to be fixed and R is just a constant, we just have to plug in different values of P and V here. So that's exactly what we're going to do. So up here, we'll have that the temperature T is 25 pascals times 4 meters cubed over 0.10 moles times the ideal gas constant, 8.314 joules per mole Kelvin. And we can illustrate how all these units will cancel out here, or at least the moles, without breaking down the pascals over here. And if we calculate that, we will end up with 120 Kelvin. And so all these other examples here for B, C, and D will be identical to this one. So if we calculate it for B, doing the exact same thing, we will get that the temperature for B is 180 Kelvin. And let's see if that makes sense. So we went up to a higher pressure and a higher volume than the last example. And based on our equation over here, if P and V were both to go up, then our temperature would also go up. Now, similarly, again, doing the exact same process, if we plug in our values for C, we will get 120 Kelvin. So this temperature has the exact same value as the first one, but it has a different pressure and volume. So this one has a lower pressure, but a higher volume. So if we look at our equation again, if we lower the pressure, but raise the volume, we can still end up with the same temperature. So they'll balance each other out. And then finally, we do the exact same calculation for D, and you should end up with a value of 180 Kelvin. Which again is the exact same temperature as part B, but for a different pressure and volume. So there you go. Using the ideal gas law, we just calculated the temperature of 4 different gases for which we knew the number of moles of gas, the pressure, and the volume.